Well, hello there guys, here Mr. G with another video. This time is another video for the grade 10, the writing very soon, and I want to also help those learners there. Now, this is going to be question about longitudinal wave. It's a very small question. This was done in June 2013, as you can see there. And we're going to start with the question. Before that, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. The question says, draw a diagram to represent a longitudinal wave in a spring, showing the direction of motion of the wave relative to the direction in which the particles move. On your diagram, also indicate compression and rarefaction. Now, to draw this one, guys, is quite tricky because it is uncomfortable to draw it. Now, this is my spring. It's quite complicated. It's not so easy and nice to make it, but this is my spring. This is my drawing. It doesn't need to be beautiful as long as it's correct. Now, remember, you have to show some regions in that spring where the particles of the spring is close to each other. Those are the compressions, okay? So it must be shown there. And there must be regions or parts in that spring like this one here when the spring is far apart, which is the rarefaction. They don't say indicate which one is the compression and rarefaction, but they say indicate the direction of motion of the wave. For instance, this wave can be moving in that direction. Motion of, let's say, wave is in that direction. You do have to indicate that one. But you know, they say indicate the compression and rarefaction. Okay, so we say the far part is the rarefaction. Those are the rarefactions. And the close ones are the compression. You have two compressions in my spring and two rarefaction. That is important. So now the motion of the wave is in that direction, but be careful with the particles. Or let's say how you represent the particles, because the particle will be moving also parallel but in both directions. So when you draw the arrow, you make sure you draw a double arrow there. This one is motion. Let's write it like this. Let me just clean that one. Motion of particles. So this double arrow here indicates the motion of the particle. They're going to move parallel, but they're going to move front and back. Okay, so that's all. Now define amplitude of a longitudinal wave. So we can say that the amplitude is the maximum displacement of a particle from its equilibrium position. That is what we call amplitude. Right? That is the definition of amplitude. It is important. Now, a longitudinal wave have a compression to rarefaction distance of 8 meters. It takes 4 seconds for this part, so it takes 4 seconds to travel those 8 meters. That 8 meters, guys, is the distance that is going to travel. It's tell you there, and this is the time for that distance. Okay, so to move past that point, determine the speed. So in this question, it's very simple. Speed is equal to distance divided by time. There we go. So if the distance is 8 meters in 4 seconds, so it's 8 divided by 4, guys, it is 2 meters per second, and this is the answer. This is the speed of the wave. This is question 3. This is about longitudinal wave. It's quite important. Thank you for watching. I hope it helped. If it helps, subscribe for the channel, thumb up. I'll see you next time. Mr. G here.